Hello everyone and welcome to this detailed video on how Git actually works. Today I will walk you through the inner working of Git, a distributed version control system. If you are new to Git and GitHub, don't worry. I will explain everything step by step, ensuring that you gain a deep understanding of the concepts. Git is a version control system. Its primary purpose is to manage changes to files and projects over time. Version control allows multiple developers to work collaboratively, track changes, and revert to previous versions if necessary. Git is a distributed system, which means that you can work on your project offline. When you connect to internet again, Git will synchronize your local copy of the repository with the remote repository. This means that you can work on your project from anywhere, and you don't have to worry about losing your changes. It is a very powerful tool, and it is used by millions of developers around the world. So how does Git work? At its core, Git is a database of snapshots. Every time you make a change to your code, Git takes a snapshot of your project. This snapshot includes the contents of all your files, as well as the metadata about those files, such as the author, the date, and the commit message. Git stores these snapshots in a special directory called the .git. The .git directory is hidden by default, but you can view it by opening your project folder in a file explorer. The .git directory contains three types of objects: commits, trees, and blobs. Commits are the snapshot of your project. They contain the metadata about your changes as well as a reference to the previous commit. Git uses a SHA-1 hash to uniquely identify each commit object. The hash is a 40-character hexadecimal number that is generated from the contents of the commit object. The SHA-1 hash is used to ensure that the commit object has not been tampered with. Trees represent the file structure of your project. They contain the list of all the files in your project as well as the SHA-1 hash of each file. Blobs are the actual content of your files. They are stored as a binary data. Git stores its data in a compressed format, which makes it very efficient. This means the Git can store a lot of data in a small amount of space. When you make a change to your code, Git creates a new commit object. This commit object references the previous commit as well as the trees and blobs that have changed. Git also keeps the track of the branches in your project. A branch is a pointer to a specific commit in your history. You can use the branches to work on different versions of your project at the same time. It is essential to identify where our code is stored. The common assumption is that there are only two locations. One on a remote server like GitHub and the other on our local machine. However, this isn't entirely accurate. Git maintains three local storages on our machine, and which means that our code can be found in four places. Working directory. The working directory is a directory in which you are currently working. Any changes you make to your file are stored in the working directory. The working directory is where you will be editing your files. Staging area. The staging area is a temporary location where files are kept for the next commit. When you run the git add command, the file is added to the staging area. The staging area is where you can review your changes before committing them to the repository. Local repository. Local repository is the central location where Git stores all of your data. The repository contains all of the commits, trees, and blobs that make up your project. The local repository is where your changes are stored permanently. Remote repository. The remote repository is a repository that is hosted on the server. You can push your changes to the remote repository and you can pull the changes from the remote repository. The remote repository is where you can share your changes with other teammates. Now let's go through some common Git commands that you can use to operate between these areas. The first step is using Git to initialize a Git repository. This can be done by running the following command in your project directory. Git init. This will create a hidden directory called .git in your project directory. The .git directory contains all the files that Git needs to track your changes. Once you have initialized a Git repository, you can start making changes to your code. When you make a change to the file, Git will add the file to the staging area. The staging area is a temporary area where Git stores all those files about to be committed. To add a file to the staging area, run the following command: git add file name. For example, to add the file index.html to the staging area, you would run the following command: git add index.html. Once you have added all the files that you want to commit, you can commit your changes. Committing your changes creates a snapshot of your project. This snapshot includes the contents of all the files in your staging area, as well as the metadata about those files. To commit your changes, run the following command: git commit -m commit message. The -m flag is used to specify the commit message. The commit message is a brief description of the changes that you have made. For example, to commit your changes with the message added a new feature, you would run the command git commit -m added a new feature. Once you have committed your changes, you can push them to the remote repository. A remote repository is a repository that is hosted on a server. To push your changes to the remote repository, run the following command: git push remote name branch name. For example, to push your changes to the remote repository called origin on the branch called master, you would run the following command: git push origin master. You can also pull the changes from a remote repository. Pulling the changes brings the changes from the remote repository into your local repository. To pull changes from a remote repository, run the following command: git pull remote repository name branch name. For example, to pull changes from the remote repository called origin on the branch called master, you would run the following command: git pull origin master. The git clone command is used to create a copy of existing Git repository. This is a useful command if you want to work on a project that is hosted on a remote server. Git checkout command is used to switch to a different branch or to a specific commit. Branches are a way to work on different versions of your project at the same time. Commits are snapshots of your project. The syntax for the git checkout command is as follows: git checkout and branch name. For example, to check out the master branch, you would run the following command: git checkout master. This would switch you to the master branch. You can also use the git checkout command to check out the specific commit. To do this, you will need to specify SHA-1 hash of the commit. The git checkout command is very versatile command. You can use the -b option to create a new branch and check out it at the same time. You can also use -f option to force checkout, even if the working directory is dirty. Use git merge to integrate the changes from one branch into another. This is a useful command if you are working on a different branches of the same project and you want to combine your changes. The syntax for the git merge command is as follows: git merge and branch name. For example, to merge the feature branch into the master branch, you would run the following command: git merge feature. It is now a good time to understand the merge conflict, which can occur while merging two branches. A merge conflict is a situation that occurs when two branches have made a changes to the same file. When you merge the two branches, Git cannot automatically determine which changes to keep. There are different ways to resolve merge conflict. You can use the git merge tool command to help you resolve conflicts. The git merge tool command will open the file in a merge tool. The merge tool will allow you to compare the changes made by the two branches and to resolve the conflict manually. You can also resolve the merge conflict manually by editing the file yourself. Some other useful commands are git status. The command shows the status of the working directory and the staging area. This is a useful command to run to see what changes you have made and what changes are still staged. Git log. The command shows the history of your commits. This is a useful command to run to see what changes have been made to your project over time. Git diff. This command shows the differences between two commits or between your working directory and the staging area. This is a useful command to run to see what changes have been made to a file. Git reset. This command resets your working directory to a previous commit. This is a useful command to run if you make a mistake and want to undo your changes. Git allows you to work on different versions of your project at the same time. This is done by creating branches. A branch is a pointer to a specific commit in your history. To create a new branch, run the following command: git branch name. You now have a deep understanding of how Git works. Remember, practice is the key to mastering Git, so don't hesitate to experiment with different scenarios. Git is a tool for modern software development, and with this knowledge, you are well on your way to becoming a proficient Git user. Thank you for watching, and happy coding.